Reynolds Experiment. Objectives to determine characteristics of laminar and turbulent flows. Equipment Reynolds apparatus, dye, water tank. Theory whenever a fluid is flowing through a pipe, the flow is either laminar or turbulent. When fluid is flowing in parallel lines or laminate, sliding past adjacent laminar is called laminar flow. When fluid does not flow in parallel lines and there is intermingling of fluid particles, then the flow is said to be turbulent. Extents of these two types of first demonstrated by Osborne Reynolds in 1883. The apparatus consists of the constant head supply tank supplies with water. Tank is provided with a bell mouth outlet to which a transparent tube is fitted. At outlet of the tube a regulating valve is provided. A dye tank containing colored dye is fitted above the supply tank. The water flow through pipe and dye is injected at the center of the pipe. Velocity of flow is low, then dye remains in the form of straight filament. As the velocity of water is increased, a state is reached when the dye filament becomes irregular in floating water. With further increase of water through the tube, dye filament becomes more and more irregular and ultimately the dye diffuses over the entire cross section of the velocity at which the flow changes from laminar to turbulent for the case of given fluid at given temperature and in a given pipe is known as critical velocity. The state of flow between these two types of flow is known as transition state or flow in transition. The occurrence of laminar and turbulent flow is governed by relative magnitude of inertia and viscous force. Reynolds related the inertia force to viscous force and arrived at the dimensionless parameter now called Reynolds number. This is the setup for Reynolds experiment to analyze forces on floating bodies and understand fluid in relative equilibrium.
Reynolds experiment. This section will attempt to illustrate Reynolds experiment. Have a look into the setup that is required for this experiment. A water tank is installed with a see-through, that is a transparent plastic or glass flow pipe, and its bottom the flow of water through the pipe is controlled by tap, and it is output side. Lastly, an ink injector is positioned at the input side of the pipe. Open the tap partially so that the water flows slowly through the see-through pipe. Make sure that there is a constant rate of flow. Observe as a steady stream of ink starts flowing through the pipe. You should observe something similar to liner line. This indicated that the water was flowing in parallel streams which I did not interfere with each other. This type of flow pattern is called streamline or laminar. We can observe that exogenous regions wherein the oscillation in the flow were unstable and any disturbance would quickly disappear. Now fully open the output tap and observe the flow of ink through it. As the water flow rate was increased, definite velocity called the critical velocity was reached. Oscillation appeared in the thread and the thread of the colored water became wavy, gradually dispersed, and the entire mass of the water in the tube became uniformly colored. The turbulent flow is characterized by the rapid movement flow in the form as in random direction across the tube.
Thank you for watching this video.